Further definitions related to the dielectric materials. Let us see what is meant by dipole moment. Now, name only implies dipole moment. So, di means two, pole means two poles. So, when two charges, equal and opposite charges, will be separated by distance, some distance, it will be called as dipole. So, dipole means when two charges will be displayed by some distance d, they will constitute dipole. But what is dipole moment? So it will be a vector with directions. So we can define dipole moment as two charges of equal and magnitude, equal in magnitude, but of opposite polarity. So two charges equal and opposite, equal magnitude, but of opposite sign. So if you see value of Q, suppose I will say Q is 5 coulomb. So this will be minus 5 coulomb and this will be plus 5 coulomb. So two equal and opposite charges. Dipole moment is defined as two charges of equal magnitude but of opposite polarity, distance d apart constitute a dipole moment. So distance d apart. If they will be concentrated at one point, then you will not get dipole moment because positive charge and negative charge are coincident with each other and they will get cancelled and atom as a whole will be neutral. So in that case, you will not have any dipole moment. But whenever you have dipole moment, it means that two charges distinctly you can see in the atom or in the material and they will be displayed with some distance d. So dipole moment is defined as the product of charge and the distance between the two charges. So dipole moment is defined as product of two charges, product of the charge and distance between the two charges. Then what will be unit of this dipole moment? Unit of charge is coulomb and unit of distance is meter. So unit of dipole moment will be coulombs meter. C dash M. This is also called as Debye. So write down this term. It is the scientist name. So Debye, scientist Debye has given this equation. He has explained about the dipole moment. So this coulomb meter is also called as Debye. So 1 Debye V is equal to, now this coulomb meter and Debye relationship. 1 Debye is equal to 3.33 into 10 raised to minus 30 coulomb meter. So remember this relationship between Debye and coulomb meter. Now polarization, you can see dipole moment, you can just give this small p, okay, though that is equal to q into d. Dipole moment is a vector. This is a vector. Direction is important. Now what will be the direction? Orientation of the dipole moment will be from negative charge to the positive charge. Okay, so dipole moment is a vector. It is from negative to positive charge. So you have to consider this vector from negative charge to the positive charge. And denotation, I mean symbol is small p or mu is used. In some books mu is used. So either you can remember dipole moment as a mu or small p. Okay, so this should be small p. Now polarization. Next definition is polarization. So what is the polarization? Polarization, it is defined as definite orientation of the dipoles in a material due to an applied electric field. It can also be defined as total number of dipole moments per unit volume. Suppose I will consider this much volume. Okay, this much volume I will consider of the material. And I will see how many dipole moments are there. That dipole moments, I will say, suppose 10 dipole moments are there in that per unit volume. So polarization is defined as the definite orientation of the dipoles in a material due to applied electric field. Because when you will see dipole moment, earlier dipole moment is, now it is in absence of electric field. We are not applying any electric field across this dipole moment. So dipole moment means two charges will be splitted with some distance and direction of this dipole moment is horizontal from negative to positive. Now suppose I will place electric field across this. Okay, so suppose negative will be this side and positive will be this side. So this positive and this positive field applied will means repel each other. So this dipole moment will try to shift its direction. It means that when electric field will be applied, then this direction will change it. Orientation will change. Reorientation will take place, and therefore we can say material is polarized. Material is polarized. So polarization is nothing but definite orientation of the dipole moments in presence of applied electric field. So polarization is defined as the definite orientation of dipoles in a material due to applied electric field. So in simple, it can be defined as total number of dipole moments per unit volume. So in this volume, there are 7 dipole moments. So polarization is 7 per unit volume. Okay. So unit of polarization will be coulomb per meter square, because coulomb meter is the unit of dipole moments, and you are finding dipole moments per unit volume. So per unit volume means that will be meter cube. So meter cube will be in the denominator and coulomb meter is in the numerator. So coulomb meter in the numerator and meter cube in the denominator. Volume will be in meter cube. So 1 meter will get cancelled. Numerator 1 meter will get cancelled with 1 meter from the denominator. So unit of polarization will be coulomb per meter square. Note down. So degree of polarization depends upon the density and dielectric constant of the material. Of course, it has to be. Polarization degree means how much will be polarization, higher or less polarization. Its degree will depend upon the density. How many dipole moments are there? Whether density is higher, polarization will be higher. If density is less, polarization will be less. And of course, dielectric constant, because if dielectric constant will be more, means material tendency will be more and more to polarize. If dielectric constant is less, means no, tendency of material to get polarized will be less. So two terms today you have just revised it, polarization and dipole moments. So it is found that for many dielectric materials, the polarization vector is related to the electric field E in the dielectric in a simple manner. So polarization P, capital P will be equal to number of dipole moments into means this is number of dipole moments into dipole moments. So small p is dipole moment and capital P is polarization, where n is number of molecules per unit volume. We are considering polarization is number of dipole moments, and number of dipole moments will depend upon the molecules. How many molecules will be there depending upon the dipole moments will be there. So polarization P is equal to n into P, where n is number of molecules per unit volume. So polarization P will be equal to epsilon 0 psi. This is psi, small x. Don't write down that capital X. So X symbol, you know how it is drawn. So that's susceptibility. E means electronic. Okay. Epsilon 0, constant of proportionality will be psi suffix E. Electronic susceptibility or electric susceptibility into E. Okay. So E is electric field intensity. So polarization P is equal to epsilon 0 psi E into E, where psi is known as electric susceptibility. So we'll see definition of this also, electric susceptibility. So permittivity, you know. So what is the electric susceptibility? So what is the equation? Susceptibility, constant of proportionality is for polarization and electric field intensity. So polarization P is equal to epsilon 0 susceptibility into E. So this is the constant of proportionality for the polarization, which depends upon the electric field intensity. So electric susceptibility is the quantity to measure the polarization in the material. So it is a constant of proportionality for the polarization. Therefore, it is defined as the ability of the material to become polarized. So if susceptibility is more, material will be polarized more. So ability of the material to get polarized is known as susceptibility and differs from one dielectric to the other. Different dielectric materials are there. Depending upon the susceptibility constant, you will get polarization, and it is a dimensionless parameter. So remember, susceptibility is a dimensionless. And now next definition is polarizability. Okay. Polarization, dipole moments, polarization, susceptibility and polarizability. Four definitions. Four definitions were basics. Electric field, coulombs, field density, that definitions were not new to you, but here these new four definitions you have to remember. So what is polarizability? Polarization ability. Split up this. Name only implies polarization ability. So polarizability. So due to external applied electric field, I told you, in absence of electric field, there will be dipole moments. But when you will apply electric field, dipole moments will change, directions will change, orientation, reorientation will take place. So due to external applied electric field to a dielectric materials causes a displacement of electric charges, giving rise to the creation and reorientation of the dipole moments in the material. The average dipole moment of is proportional to electric field strength E. Therefore, dipole moment, not polarization. Dipole moment is proportional to E. Earlier we have seen polarization is proportional, susceptibility into E. But here dipole moment is proportional to alpha into E. The proportionality factor alpha is polarizability. So you can just see both are P, but one P is small and one P is capital. So when small P is there, it represents dipole moment. When capital P is there, it represents polarization. When you consider capital P and E equation, constant of proportionality is susceptibility psi. But when you see dipole moment and intensity, electric field intensity, constant of proportionality is polarizability. Very little difference is there. You should not confuse, note down in the tabular form, difference form. And if you will remember in difference form, your concepts will be clear and no confusion will be there. So polarizability, proportionality factor alpha is called polarizability. Now polarizability will be definitely dipole moment divided by E. It is defined as the electric liability. Susceptibility was the capability, ability. Now here polarizability is, you can just see it is the liability. Meaning is same, but the words are used different. So it is the liability of the particles to induce dipole moments with the applied electric field strength. It can be defined as induced dipole moment per unit electric field strength. Then the unit of polarizability is farad per meter square. So it is not dimensionless. Okay. Polarizability is not dimensionless, but polarizability dimension is farad per meter square, whereas susceptibility is dimensionless. So I will tell you, write down the difference between polarizability and susceptibility. Write down your own points you create. I am giving you 1 minute time. Write down the difference between polarizability and susceptibility. Polarizability unit is farad meter square. Susceptibility unit is dimensionless. Susceptibility is X. Polarizability is alpha. It is the constant of proportionality for dipole moments. And susceptibility is the constant of proportionality for the polarization. Okay. Write down. This difference you write down, and then there will be no difficulty. Polarizability is the liability. Okay. Polarizability is the liability. Whereas susceptibility is the ability to get polarization. So now you just write down 7, 8, equation 9. What was the 7? You just see 7 equation. Just write down these 7 equations. Students, you write down fast so equations. Okay. And then we'll see some steps. So I think you have understood these 4 basic definitions. And remember formulae, write down, and then we'll just see some equation. Come on. Just revise these 4 definitions. Then we'll go ahead.